Today we're going to learn about naming compounds, otherwise known in chemistry as nomenclature. And all nomenclature is a systematic method used to write formulas and the name for different compounds. These include ionic, covalent, and acids. So before we begin, you need to understand the rules. So before you even begin, you know already some things about formulas, names. So if you look at nomenclature, let me erase that right there. Nomenclature, or a name, you already know sodium chloride, and you know the formula for sodium chloride, that's NaCl. So what is a name? A name is simply that, like sodium chloride. Or what's the name for this formula? Oh, you say water, and I also say it can be called dihydrogen monoxide, but we'll talk about that later. So to differentiate between things, a name is that, words that name something. And a formula shows symbols, chemical elements written in a pattern, and sometimes there's subscripts, and sometimes there's not. Now, if I was to tell you H2O, there's really a 1 there, but we don't write that. Okay? So formula is chemical symbols, and a name is just that, a name. Now, before you even begin, you'll notice there's a green staircase on this periodic table. And what this does is this separates the metals, which are over on this side. On the left-hand side live the metals, and over on the right-hand side are the nonmetals. So these are nonmetals, and these are metals over on this side, right here. And what separates them is a staircase. Oops, I don't want that color. Is a staircase. And that is a dividing line called the metalloids or the semimetals. And that simply separates the metals from the nonmetals. It's like a giant fence. So if the first element, and this is important because if the first element begins with a metal, the compound is ionic. So on this side of the fence are the metals. And if the first element's a metal, these are ionic. If the first element's a nonmetal, then you have a covalent compound. Right? And we'll talk about that real in detail here in this podcast. So the bottom line with ionic compounds, which remember the first element begins with a metal, is that a metal loses its electrons. A nonmetal, oops, that should not be loses. See, proofread. This should say gains electrons. Okay? And so what happens, if you can picture an electron like a ball, the metals have electrons, and they throw them to the nonmetals, and the nonmetals have mitts out. So those negative signs that you're going to see shortly are the metals and the nonmetals. The metals throw the balls to this mitt, and the electrons are caught. So it's a game of throw and catch, or lose and gain. So before we even begin, you need to understand that there's charges. So again, you know that dividing line right here between the metals and the nonmetals. And we'll stick with our colors here. These are +1, +2. You'll learn why later, okay? These are different. We're not going to talk about these right now. These are +3. These are -1, -2, -3. Almost like a number line. If you could say this was 0 and you want a negative direction, okay? So +1, +2, +3, and this can be +4. This is 0, -1, -2, -3, and this can be also -4. So on your periodic table that you should have out, you need to copy down these basic charges so you can understand them. We'll come back to them in more detail later, but for now you need to understand these. So I've written these on this periodic table, and if you look, we're going to write formulas for these ionic compounds. Now we already know that the metals lose electrons and the nonmetals gain electrons. So we're simply going to name these like Mr. and Mrs. because that's what they form. They form a nice happy couple, a compound, okay? And that compound is an ionic compound. So let's look and see what the charges are. Sodium, and I'm going to go ahead and just use blue, okay? Sodium has a positive 1. How did I find that out? I looked on the periodic table right here, and here's sodium. It's in the +1 column, so I write +1. Chlorine is in this column right here. It's in the -1 column. So what's that mean? Sodium's throwing an electron, and chlorine's catching. One ball being thrown, one mitt out to catch. So therefore the compound is written NaCl. Okay? Now, let's look at the second one. What do we have here? Here's Mg. Mg is in the +2 column. And oxygen is right here. It's in the -2 column. So what's going to happen if magnesium, who has 2 electrons or balls, throws 2 oxygen, who has 2 mitts out? They're playing ball evenly. Magnesium and oxygen are here to play. And if magnesium's throwing 2 balls and oxygen has 2 mitts out, then you write it MgO because they're in a 1-to-1 relationship. I'll draw you a picture. Mg throwing 2 balls, oxygen has 2 mitts out. Magnesium throwing, oxygen catching, and it's equal. You see 1 Mg and 1 O. Let's look at lithium and sulfur. Let me use a different color. Lithium's here. It's in the +1 column. Sulfur's in the -2 column. And you know what, let me get rid of this for you so that it's not, that's a big eraser. Sorry. Okay, so now what's going to happen? Lithium's throwing 1 electron. Sulfur's catching 2. So it means you need 2 lithiums to play ball with sulfur. So I write Li2S. There's a picture. Lithium's throwing a ball. Sulfur has 2 mitts. That doesn't work. So you need another lithium to throw another electron to sulfur. And then what do you see? 2 lithiums and 1 sulfur. So write Li2S. What about Ca and F? Ca is here in the +2 column. F is over here in the -1 column. How are they going to play ball? Calcium's throwing. Let me erase this while we're talking. Calcium's throwing electrons. How many? 2. And fluorine's got 1 to catch. So CaF2. Because calcium throws 2 balls, fluorine catches 1. So you need 2 fluorines to play throw and catch with calcium. Aluminum, +3. That means it has 3 electrons to throw. Phosphorus is -3, 3 mitts out to catch. So you would write that AlP, a 1-1 relationship. All right? Now the last one we're going to do is barium. Let me actually do this a different color because it's a little different. It's kind of tricky, but you're okay. Use brown. So I have barium, which is in the +2 column. That means it has 2 electrons to throw. And phosphorus, we already saw, has a -3. 3 mitts out to catch. So how's that going to work? Well, you ask yourself, the smallest number they both go into is 6. So if barium has 2 balls to throw, I'm going to write this like this, and phosphorus has 3 mitts to catch, 2 times 3 is 6, and 3 times 2 is 6. So I would write this over like this. You never put charges in, because once the throwing and catching has happened, they balance each other out and they're neutral. And that's how you write that. If you need to rewind, review, do this again, do so. Let's move on to the next slide. So now we're going to write the name. So these compounds were the compounds on the slide before. We wrote the formula. Remember, this is the formula. Now we're going to write the names, and this is where the Mr. and the Mrs. come in. So we'll go back here. This is a Mr. and this is a Mrs. So you ask yourself, sodium is a metal. Magnesium is a metal. Lithium, up. You know, I should be doing this in the same color as the metals, so it makes it clear for you. Sodium, magnesium, lithium, calcium, aluminum, and barium are all metals. We already established that before. But just so you can see, remember aluminum's on this side of the fence, so it's a metal. Those are all metals. The minute the first one begins with a metal, you say Mr. and Mrs. They're playing throw and catch. So you simply name it sodium and chloride. So this is chlorine. She changes her name and it changes to ide. So what will magnesium and oxygen be? Magnesium oxide. Make my pen a little narrower. So what would Li2S be? Lithium. That's the Mr. Sulfur changes her name to sulfide. So what do these little numbers mean down here, this subscript? Does that have anything to do with the name? Nope. It has to do with how they're playing throw and catch. So that's written properly already. You don't need to worry about when you see a correctly written formula. You just name it. So you ask yourself, calcium's a metal, so I'm going to name it calcium. He keeps his names, he's the Mr. And fluorine, she changes her name to fluoride. Aluminum and phosphorus becomes phosphide. You notice that the girl, the Mrs., continuously changes her name, and it ends in ide every single time. So what would barium and phosphorus be? Barium phosphide. So again, don't get confused. All the little numbers, all the little subscripts down here just tell you how they're playing throw and catch. Your most important thing to look at here is it a metal? If the first one's a metal, it's ionic, and it's playing throw and catch, and it's a Mr. and a Mrs. Okay, and again, you can rewind this for help. So now let's go the opposite way, which means you're going to have to look at a periodic table back here. You're going to have to look up the charges and match them to what I have. And so if you have the formula, if you have the compound, you want to write the formula, you have to look up who's here to play. Sodium's here and chlorine's here because it's sodium chloride. And if you look in the periodic table, sodium's +1 and chlorine's -1. So how are they playing ball? Evenly. So you write NaCl. Barium fluoride. Barium's a metal. Matter of fact, calcium's a metal and lithium's a metal. So you know these are all ionic. These are all Misters. And these are all these are all Mrs. Right? That's why she changed her name. So how do I write barium fluoride? I use a different color so you can see it clearer. Barium on your periodic table is +2 and fluorine's -1. How are they going to play ball? Well, barium has 2 balls to throw and fluorine has a mid out, so you write BAF2. Calcium phosphide is Ca, that's +2, and phosphorus, which is -3. We're going to do that smallest number they both go into. That's 6. So you write Ca3P2. Ca has 1, 2 balls. Phosphorus has 1, 2, 3 mitts. That works, except phosphorus needs another ball. That works, except you need to get rid of that ball, so you need another phosphorus. That works, except you have 2 more mitts. So now look at that. What do you see? 3 calciums and 2 phosphorus. And that's why that works. The last one is lithium and oxygen. Lithium is +1 and oxygen's -2. So you write Li2O. You need 2 lithiums to play ball with 1 oxygen. Now, what happens if the first element's a nonmetal? Well, now you have what's called a covalent compound, if that's even a good color. So if you look, what was our dividing line again? Our dividing line was here, right? That separated the metals from the nonmetals. Metals are on this side and nonmetals are on this side. So I'm going to play a game and we're going to call this Greece. So everything in this area is Greek. And when you're in Greece, you speak Greek. And the Greek prefixes are mono, 1, di, 2, tri, 3, tetra. It's like Tetris is 4, and 5 like pentagon. And then there's hexa. Oh, that's not a good color. Sorry. There's hexa, and there's deca, there's octa, there's other prefixes. But for now, let's just use these so you can understand. So I've kind of cordoned the periodic table off here, and if you look, the very first element here is a nonmetal, carbon. It's on this side of this line, isn't it? So here's carbon, a nonmetal, nitrogen, a nonmetal, phosphorus, a nonmetal, carbon, we already established that, phosphorus, we already established that. So why are we going to use tri or penta or mono? Because we are in Greece, so you speak Greek. And where's Greece? Everywhere on this side. That's where the nonmetals live. So how are we going to name this? Carbon is in Greece. It's a nonmetal. So you're going to name it carbon dioxide. You already knew that, didn't you? So look at that. That's why you're using di, because carbon is a nonmetal. What about this one? This is nitrogen. There's 2 of them. So I'm going to call it dinitrogen pentaoxide. Now really, truly, it rolls off the tongue better if you say pentoxide, so that's what we do. This one is phosphorus trioxide. And if you notice, if there's only one to start off with, we don't use mono. But if there's one at the second one, you're going to use mono. So C is carbon. Oxygen is O. How many are there of it? 1. So you write carbon monoxide. What's this compound? Phosphorus, and we're using this tri and penta because phosphorus is here. There's 3 phosphorus, and hydride is just hydrogen, and there's 5. So what you need to understand is that there's no throwing and no catching when you're in Greece. These guys are covalent, and they are sharing electrons. And so the only way I can tell you is to use these prefixes. Now, let's flip back to ionic compounds again. Ionic compounds, if you look where this purple area is, we didn't talk about what charges, right? These were +1, +2, aluminum's not in this purple area, okay? So we're not talking about any of this at all. None of this. We're talking about the metals, okay? Remember, they're on this side of those stairs. Metals. All in this purple area, okay? And this is where we use Roman numerals, or the fancy name is variable oxidation states. And we use Roman numerals to tell us the charges. So the Roman numerals are 1, which is this, 2, because how awful would it be if you didn't understand or you didn't remember what the Roman numerals were? And this is 6, 7, 8, 9, and 10. If you don't know those, pause it. Okay. So let's look at these. Iron 2 chloride and iron 3 chloride. Why in the world are we using Roman numerals? Well, if you look, where's iron live? Oh, it lives in this area, doesn't? Whoops. Sorry. It lives in this area. That's like a bunch of Roman soldiers walking back and forth along this wall. See them? Back and forth. Aluminum's not in here. And then if you think about it, if I'm a Roman soldier, who's going to replace me? Here's my shift that's going to replace me. They're sleeping, and they're going to come back and they're going to replace me as I walk in this whole area. So this is the stockade. That's where the Roman numerals are used. Okay, so iron 2 chloride, what's that mean? That simply means that there's iron and there's chlorine, and this is a +2 charge. I'm doing that because I don't know iron's charge, right? I didn't tell you rules for this area. Chlorine, however, is -1. So how they playing ball? Iron's throwing 2, chlorine's catching 1, and so you make it FeCl2. If you notice, it's still a Mr. and a Mrs., but now he's a Roman guy. And why is he Roman? Because he lives in Rome. So what's this iron 3 chloride? Iron 3 means that this iron has a charge of 3. That goes up high, it's a charge. Chlorine has a charge of -1. So how are you going to write this compound? FeCl2. So if you look, if we just used our Miss or Mrs. iron chloride, this would also be iron chloride, wouldn't it? Iron chloride. But they're not the same. Oops. This, I am so sorry. This is a 3 because this is throwing 3. Okay, better? So let's go back and I'll give you some compounds. For instance, NiO. So let's figure out what that is. Well, oxygen's -2. I don't know nickel. Nickel's another Roman guy. So how am I going to do this? Well, I gave it to you, and it's written correctly, NiO. That means if oxygen's -2, then what's nickel have to be? If there's one of each of them. Draw a picture if you have to. Oxygen has -2. That means it has 2 mitts out. There's 1 nickel. How many balls must this nickel be throwing? 2. Doesn't that make sense? If nickel's throwing 2 electrons, it matches up equally with oxygen. So I'm going to name this nickel. I don't know yet. Oxide. Still Mr. and Mrs. What goes in there? This 2, and that's Roman numeral 2. And that's how that works. Okay, there's more in some of the worksheets I gave you, and we'll do some more in a minute too when we come back to polyatomics. Now, it's real important that you understand what a binary compound is. A binary compound has 2 elements. 1, 2, 1, 2, 1, 2, 1, 2. Okay, those are binary compounds. This is called calcium chloride, a metal and a nonmetal, Mr. and Mrs. This is called lithium bromide, LiBr, because lithium's throwing 1 and bromine's catching 1. Where's carbon land? Oh, look. It's on this side of the stairs, so it must be Greek. So I'm going to call that carbon dioxide. Why am I using di here? That's because nitrogen is a nonmetal. So this is N2Cl4. And if you notice, these all have 2 elements, so they're binary compounds. It's real important you understand that, because if you run into a compound that is ionic, because it will be ionic, They're going to have polyatomic ions in the compound. It is not binary. It has 3 or more elements in a compound. So before we go further, you need to memorize these polyatomic ions. Phosphate, sulfate, carbonate, nitrate, hydroxide, and ammonium. And these are a clique. So let's look at the phosphate clique. There is 1 phosphorus and 4 oxygens. That's a total of 5 people. Okay? It's like they're tied together with a rope, and they have 3 mitts out. You can picture that. 5 different people tied together with a rope, and they have the potential to catch 3 electrons. They have 3 mitts out. So if that's true, what would be in this sulfate clique? 1 sulfur and 4 oxygens. How many mitts do they have out? 2. How many mitts does this group have out? 1. Who lives in that clique? 1 nitrogen and 3 oxygens. And it has a -1 charge. It can catch 1 electron. The only positive polyatomic ion is ammonium, and it's +1. That means it has 1 ball to throw. Okay, so you need to look at those, and you need to memorize them or write them down. And now we're going to use these. Okay, and I'll flip back and forth between this page and the next one. So if you look, let's count. Let's move this up here. 1, 2, 3, 1, 2, 3. These are not binary, are they? See, not binary. They have 3 or more, every single one of them. And on these, I know there's nitrate 8. The other ones ended in I, didn't they? Okay, and the only one that's an exception, well, there's a couple exceptions, but for now, this is hydroxide. It's an exception. Okay, you say, oh, that's an exception, and it's -1, hydroxide. So let's look. Lithium and phosphorus and oxygen. That's 1, 2, 3. I'm going to go ahead and circle this because that's my polyatomic ion. This is lithium on my periodic table you need to look at right here. This is a metal. So I'm going to name it Mr. and Mrs. Mr. and Mrs. who? Lithium. Who the heck is this PO4? Oh, well, on the page before, which you're going to have to look at, I'm not going to keep flipping back and forth in this, is called phosphate. So that PO4 is called phosphate. Calcium, well, that's a metal, isn't it? So I circle this and I call it calcium. And who is that clique? Well, that clique is called nitrate. Mg is a metal right here. And so this is called magnesium. It's a Mr. and Mrs., a complicated Mrs., right? So this is magnesium hydroxide. Why the little numbers here? That's how they're playing throw and catch. We'll come back into that in a minute. Wow, look at this. 1, 2, 3, 4. That means I have a polyatomic ion and another polyatomic ion. This is ammonium carbonate, because that's who's here to play. And I'll go and do a polyatomic ion podcast. This is iron. Okay, so I'm going to go back and I'm going to erase this one. Okay, just so we have room. So if you look at iron, where does iron live? Iron is in Rome. So that means it's going to be Roman. So phosphate on the page before has a -3 charge. It's a polyatomic ion. How many there are of that? There's 2. That means that PO4 has 3 mitts out, 1, 2, 3, and there's 2 of that group. So 3 times 2 is 6. So what's 3 times what is 6? 2. So I'm going to call this iron, Roman numeral 2, because that's the charge, phosphate. Nickel 2 nitrate, that means I have Ni. That Roman numeral 2 means it's +2. Nitrate is NO3. That's a clique, a polyatomic ion. The whole thing's -1. So look, if this is +2 and this is -1, how are they playing ball? You need 2 of this group, don't you? So let's circle that group and put a 2 outside. So you write it NiNO3 2. Barium carbonate, that's barium, which is a +2, and carbonate, which is a -2. They match up perfectly evenly, throwing 2 and catching 2, so you just write it BaCO3. Now aluminum, which is +3, and sulfate, which is -2, how are they going to play ball? Ignore this and look at the 3 and the 2. What do we do before? You look for the smallest number they both go into, and that's 6. So you have aluminum has 2, and sulfate, you need to circle it or put it in parentheses like this, has a 3. Our last quick addition to this podcast is acids. Now, how do I know I have an acid? Because an acid begins with hydrogen. Now, it's all about the ending. So I'm going to go ahead and take this H, and that's going to turn into the word acid for all of these, right? They all begin with H. So I'm going to go ahead and look at this. I'm going to name this hydrogen. And to save time, I'm not going to write it for each one. But this is hydrogen chloride, right? 1, 2, a metal and a nonmetal. This is a polyatomic ion, so I would call this hydrogen sulfate, right? I lied, I'll put it in. And then for this last one, this is a different polyatomic ion, which you can look up on a chart, and that's called hydrogen sulfite. So it's all about the ending. If it ends in "ide" or "ate" or "ite," you're going to have specific endings. So if it ends in "ite," I'm going to invite us over to your house. The word hydrogen already turned into the word acid over here. This sulf is going to go in this blank. And you know, chemists like to sound fancy. So instead of saying sulfus, we say sulfurous. That's one of the exceptions. Hydrogen sulfate, the word hydrogen turns into the word acid. And ate, if I ate something, I get ick on my teeth. So I invite us to your house. If I ate something, I get ick on my teeth. And this root goes in here, so I call it sulfuric acid. Now, how do I do this? Hydrogen becomes the word acid. If it ends in "ide," go figure, it's got the most complicated ending and name. So with "ide," I'm going to put chlor in this blank. I had a hard time remembering these at first, but if you look, these two acids have oxygen. This one doesn't. So it's almost like you're adding an oxygen when the word hydro, like water. Okay, if that helps you remember it. So this is going to be hydrochloric acid. So let's practice. I'm going to go through this quickly. You can pause it. HBr, that's hydrogen bromide. Now I'm not going to write the word hydrogen here. Okay, I'm just going to write the endings. Hydrogen bromide, hydrogen carbonate, and hydrogen carbonite. So what do we say about the endings? If it ends in "ite," I'm going to invite us over to your house. Oh my gosh, what's going on? Erase this. There we go. Okay, so this is going to be carbonous, right? That's the carbon. And that H is going to turn into the word acid. If it ends in "ate," I get ick on my teeth. And again, that H becomes the word acids. So it's going to be carbonic. Bromide, go figure, it had the most complicated name, hydroblankic acid. And this brom goes in here. So it's bromic. And the acid was the H. Now working the other way, hydrofluoric acid, that means you have H and you have F, right? The word acid turns into an H. This is +1 and -1, so you write it HF, and that's hydrofluoric acid. Phosphoric acid, if it ends in ic, wasn't that 8? So this turns into phosphate. The word acid was the hydrogen, so I'm going to write it here. So H. Phosphate is PO4. This is +1 and -3. So the compound's written H3PO4. Last one, sulfurous acid. I invite us over to your house. So remember, sulfur was one of those funny ones. It's not sulfurite, it's sulfite. The word acid turns into hydrogen, which is +1. Sulfite is SO3, which is -2. What are they going to do when they play ball? Throwing 1, catching 2, so you have H2SO3. I know that was quick, but you can rewind and look at it again. And if you want, you can go to my website and have more practice. Good luck, and look for my podcast on polyatomic ions. It'll go into a little more detail and also about Roman numerals.